In section 3.2, as you can see, we are going to be talking about the graph of a function. There are two big takeaways from this lesson. I want you to be able to identify the graph of a function, and then we're going to be looking at functions and pulling out information from and about the graph. So that's really where we're going to begin with our first example. At this point, you really need to have your textbook open to page 218. If you don't, you can go ahead and just pause the video until you get there and then start it back up. So I hope you've had a chance now to open up to page 218, and we're going to walk through problem number 9, and I'm assigning problem number 10 for you as part of your homework assignment, but I think after you've seen number 9 you'll see how this works. So we're going to be looking at that graph on page 218 and answering several questions, as you can see. So let's just jump right into this problem. The letter A, it's a two-part. It says to find f of 0 and f of negative 6. So in other words, f of 0 means if you input 0, if 0 is the x-coordinate, what would be the resulting y-coordinate? Well, f of 0, as you can see, the point 0, 3, 0 is the input and 3 is the output. So you're looking for ordered pairs that have an x-coordinate of 0, and the answer will be the y-coordinate of that ordered pair. Same idea for f of negative 6. If you input negative 6, then you should get a particular y-coordinate, which we call the output, and hopefully you can see that that would be negative 3. You see over there on the far right side, the very left, bottom left in quadrant 3 point has an ordered pair of negative 6, negative 3. So you're looking at these are the inputs, and then look for a y-coordinate that has that x-coordinate. Alright, same idea for letter B. What is f of 6? Well, if 6 is the input, then apparently 0 is the output. I see the point 6, 0 there, of course, on the x-axis. And then the second part of that problem is what is f of 11? Alright, so look for an ordered pair where the x-coordinate is 11 all the way to the right, and the y-coordinate would be 1. Okay, not too bad. Letter C says, is f of 3 positive or negative? Well, we don't know exactly. We don't have the ordered pair for f of 3, but we do know it would be between the points 2, 4 and 4, 3. Whether or not it's positive or negative, obviously it's got to be up there in quadrant 1 where y is positive. So my answer for part C, the f of 3, which means if I input 3, what would the output be, the y-coordinate? It would have to be positive because that point falls between the point 2, 4 and 4, 3. Similar question with part D, is f of negative 4 positive or negative? Well, f of negative 4, that point should of course fall between the point negative 5, negative 2 and negative 6, negative 3, or between negative 3, 0 and negative 5, negative 2 in that area. Well, it's pretty obvious that it's going to be down there in quadrant 3, which would mean that that y-coordinate would have to be a negative number. Okay, so that would be your answer then for letters C and D. Letter E says, for what values of x is f of x 0? So now we're kind of turning it around a little bit. You can think of f of x as y. Okay, so in other words, where do we have for what ordered pair, what would the x-coordinate be on this particular graph that has a y-coordinate of 0? Alright, so hopefully you can see these are all X-intercepts. You can see the point negative 3, 0, so one of my answers would be negative 3. You can see the point 6, 0, so second answer here would be 6, and then the point 10, 0. So my final answer here, there are 3 values of x where f of x is equal to 0, -3, 6, and 10. Okay, then the next question is for what values of x is f of x or y greater than 0? Well, that's going to be for several numbers. Any number between, for x, -3 and +6, that's going to be true. Now, that's not going to include x is -3 because that's where it is 0. We've already answered that in part E. But we'll state it like this. For values of x that are between -3 and +6, and we don't want to include -3 or 6. Okay, and then going on down and including the rest of this, the second part of our answer, we also have values of x that are between 10 and 11. Okay, all of these x values would give us a y that would be bigger than 0. In other words, these represent ordered pairs. The x coordinate of the ordered pair and the associated y coordinate would be greater than 0. So that would be your answer. Oh, and we need to include 11. I just noticed that because you notice that very last point, 11(1), that's a closed circle, meaning that 11 should be included in this answer. All right. Moving on, letter G, what is the domain of f? In other words, what's the domain of this particular function? And when you're thinking domain, you're thinking of the coordinates, the x coordinates. Think about the x-axis. What numbers, if you take in this whole graph, what range of numbers would be included in the set that we would call the domain? All right, and we're going to state it like this. The domain represents x such that, and here we're going to describe them. And it's basically all the numbers from the left side, they start at -6. And that's going to include -6 because you see the solid circle at the point -6, -3. And on the right side, again, we're just tracing along the x-axis, and we're trying to just make a list of all of the numbers that would be involved from the x-axis in this particular graph. And on the right side, it concludes all the way over at x is 11. So that would be our answer for the domain. All the numbers between -6 and +11. The range, well, now you're thinking about the y-axis and what y-axis numbers are utilized in this particular graph. So you're trying to take the graph and then look at the y-axis and see if you can make a list, a range of numbers that would be involved. And for the range, of course, we associate the letter y. So for this answer, we're going to say from -6, I'm sorry, -3, looking at the wrong number there, from -3 there at the very bottom, and extends at the top on the y-axis to +4. Okay, so again, for range, you're thinking this way. What numbers along the y-axis are being used in this graph? Just get a range from one end to the other, and then for the domain, you're thinking the same way along the x-axis. And that takes care of our range. All right. X-intercepts, we basically already answered this when we answered part E for what values of x is f of x 0, and that's just another way of saying the x-intercept. So we'll go ahead and list them again: -3, 6, and 10. There is a y-intercept. It's at the point 0, 3. So we can just say 3. Letter K, how often does the line y equals 1/2 intersect the graph? Well, y equals 1/2 is horizontal. It's just a completely horizontal line that crosses the y-axis, if you can picture it, at the point 1/2. And it looks like if you wanted to sketch that line maybe lightly with a pencil, hopefully you can see that that horizontal line will intersect the graph 3 times. Now let's take a look at the line x equals 5. That's a vertical line crossing the x-axis at 5, and that should be pretty obvious to see that that's only going to intersect the graph 1 time. Okay, we're down to letter M, almost finished with this problem. For what values of x does f of x equal 3? Okay, so in other words, another way of saying that, f of x equals 3 means we have a ordered pair where the y value is 3. Alright, so just in other words, you can go, one of them is pretty obvious, it's right there on the y-axis. 0, 3 is one of our answers, or we're just looking for the x coordinate. And then if you look straight to the right, you'll see another point that has a y coordinate of 0. It's the point 4, 3. So your two answers here are the numbers 0 and 4. And then finally, a similar question, for what values of x does f of x equal -2? So you can just go to -2 on the y-axis and then look left and right, and you should be able to see that to the left you have the point -5, -2. So -5 is an answer. And then if you go to the right of the y-axis, a little further to the right, you see the point 8, -2. So 8 is another of our answers. Okay, so you're going to do the same type of thing when you do problem number 10. I just wanted to let you use this one as a sample. And let's move on. Number 11. In this block of problems, you're asked to determine whether or not the graph is a function by using the vertical line test. And if it is, then we need to find the domain and range, any intercepts, and then symmetry. Alright, so here's number 11. The vertical line test, unless maybe you've forgotten, it says this: if I can draw a single vertical line, and that's a terrible vertical line, but if I can intersect a graph in more than one place with a single vertical line, then this is not a function. So number 11, my answer is going to be no, and therefore I don't have to worry about answering domain, range, intercepts, and symmetry. So if the answer is no, you are ready to go on to the next problem. Okay, let's try number 13. Does this one pass the vertical line test? And if you want to just take your pencil, maybe the eraser side, and just draw straight vertical lines and see if you intersect the graph in more than one place. In this case, we only intersect the graph one place at a time with a single vertical line. So my answer here is yes, this is a function. So for the domain, I'm looking from, basically I'm looking along the x-axis, and if you want to do this, this might help. You can take the end of your graph and then trace up to the x-axis, and then just identify with a range of numbers what numbers along the x-axis are involved in this graph. So we will state it like this: the domain will be x values such that they're basically falling in between -π/2, that's the left side, and +π/2 on the right. And notice that since these are closed circles, I'm going to say or equal to. If these had been open circles, then I would have just said less than without the or equal to symbol. Okay, so for the range, you're looking at y values that would be involved in this particular graph. Now the graph in the book doesn't have this little circle here or these marks. I just was using those to help identify the domain. But if it helps, on the graph in the book, you're shown that this goes down to -1. So what we're saying here, if you take this function and you compare the y-axis, the numbers that would be involved along the y-axis, we go from +1 down to -1, and I went down just a little bit below, but I think you get the picture. So the way we would state the range is all the y values such that any y between -1 and +1. And once again, since these are solid circles here, and this is going to be exactly at -1 because it's an intercept, we're going to say or equal to. Okay, so between -1 and +1 on the y, that's our range. Between -pi/2, I was looking at this pi/2, that should be -pi. Let me fix that. The green is just an intercept. Okay, the pi is actually where we're crossing the x-axis. So sorry about that. Alright, so we got our domain, we have our range, our intercepts. Now I am going to look at these 2 points. Here we have -pi/2, 0, and pi/2, 0. Those are, of course, x-intercepts. And then I've got this one y-intercept, which would be the point 0, 1. Okay, and then finally, do we have symmetry with respect to the x-axis, y-axis, or the origin? Well, if we have x-axis symmetry, then we should be able to fold on the x-axis, and the two sides of the parts on either side of the x-axis should meet together, should create the same shape on either side. Well, that's not the case. Looks like we do have y-axis symmetry, because if I do fold on the y-axis, I am going to have these two parts that would basically fall on top of each other. So there is y-axis symmetry. And then for origin symmetry, there is no there are no points. For example, you could test it this way. If I have origin symmetry, then pi/2, well, let's just take this point for example. This is the point pi/2 and -1. Okay, that's pretty obvious that that's on the graph. Well, if there is origin symmetry, then this point should be on the graph. If you just take the opposite signs, -pi/2 and +1 is not on the graph. So this kind of proves that we do not have origin symmetry, only y-axis. So that takes care of number 13. Alright, number 19, from that same block of problems, do we have a function? I think it's pretty obvious that this does pass the vertical line test. Let's state the domain. Again, we're looking at the x-axis, and we're trying to decide which numbers along the x-axis would be involved as coordinates, x-coordinates, for this graph. Well, this graph is going to go forever and ever according to these arrows, both towards -infinity and +infinity. So we're just going to have all real numbers as part of the domain. Okay, for the range. Alright, now we're looking at this way. numbers along the y-axis that would be involved. Well, it won't be all real numbers because this graph does not go forever and ever above y equals 2. It does, however, go from y equals 2 forever negative because of these endpoints. So the way we're going to state the range is y values such that y will be less than or equal to positive 2. Okay. Now for intercepts, we'll state these as ordered pairs. We have an intercept at negative 3, 0, positive 3, 0. Those are these two X-intercepts. And then we have a y-intercept here at 0, 2. Alright, let's test for symmetry. Do we have x-axis symmetry? Obviously not, because we do not have a mirrored image reflected over the x-axis, or we can't fold on the x-axis and create two equal parts. Looks like we do have y-axis symmetry. And once again, if we have origin symmetry, then I should be able to take points like the point 1, 2, and that's on the graph. And if I had origin symmetry, then the point negative 1, negative 2 should also be on the graph, which it is not. So I only have y-axis symmetry in this case. Okay, now we're down to another example, problem number 25. I think I've given you number 26. So we're just about to conclude this lesson. On number 25, they're going to give you a function, or your number 26, they're going to give you a function, and then they're going to have you answer several parts. Like letter A says, is the point 314 on the graph? Okay, well, in other words, if you input 3 in for x, this is what this says. If you have 3 as an input, does 14 come out as an output? Well, that's pretty obvious that it does not, so the answer is going to be no to part A. Part B, if x is 4, what is f of x? What point is on the graph of x? Okay, if x is 4, then in other words, we're going to evaluate f of 4. 4 plus 2 over 4 minus 6. 4 plus 2 is 6 over negative 2, and that's negative 3. So what they're really trying to get at here is, do you understand this idea of x being an input and the result being an output, and together they make an ordered pair, or they're using the word point. So the point 4, negative 3 is a point on this graph. Okay, so if x is 4, use it as an input, and then the output will give you the complete ordered pair on this particular graph. Alright, letter C, kind of a similar question. If f of x, well, it's kind of going the other way. If f of x is 2, what is x? Well, this time let's let f of x be 2, and we're going to solve for x. Okay, so I can multiply both sides of this by x minus 6. 2x minus 12 is equal to x plus 2. Okay, just multiply by x minus 6 on both sides, and I get, subtract x, I add 12, I get x is 14. Okay, so the point, what points are on the graph? Well, that's going to be the point 14. Remember, x is 14. F of x is another way of saying the y coordinate. So the point 14, 2 is on the graph of x. Okay, letter D, we talked about this a little bit in our last lesson. What is the domain? Well, the concern I've got here in this function is I cannot divide by 0. So the only problem I've got is when x is 6. So the way I'm going to state the domain is I can have x such that x cannot be positive 6. It can be any number besides positive 6. Okay, list the X-Intercepts, if any, of the graph. Well, remember, if we want to find an X-intercept, we just assume that y is 0. Alright, so we could solve it like this. Basically, in these fractions, what this amounts to is you're solving the numerator, and I'll show you why. If we just say 0 equals x plus 2 over x minus 6, if I'm going to solve this, then I multiply both sides by x minus 6, and then of course I get 0. So I do have an x-intercept, and it's at -2. So again, if you want to find an x-intercept, let y be 0. If you want to find a y-intercept, you're going to let x be 0. So I got 0 plus 2 over 0 minus 6, and I got 2 over -6, which is -1/3. So there is a y-intercept, and it's the fraction -1/3. Okay, so I hope that helps when you do number 26. Okay, now I want you to do number 29. It's a word problem on page 220, and I'm really trying to give you some help here with this. I don't want to do this for you, but I think I've set it up really well to answer all of the parts. So here's the function that's given. This is kind of an interesting problem. I love sports and I love algebra, and I really love it when we can put the two together and solve some problems, and that's what's happening in this particular case. So this physicist came up with this function to model a free throw shot, and h, of course, is given as the height of the ball. So this whole function represents the height of the ball given x being a forward distance of the ball in front of the foul line, and v stands for initial velocity of the ball. Well, they tell you in the problem, if you read through this, that v is going to be your very last sentence there right in front of part A. Suppose a player shoots a ball with an initial velocity of 28 feet per second. So right away, of course, you're going to want a calculator for this. You're going to plug in 28 for v, so you're going to have 28 squared. All right, and then part A, it says determine the height of the ball after it has traveled 8 feet in front of the foul line. Well, in essence, after you replace 28 or v with 28, as you're told in the problem, you're in essence going to evaluate h of 8, which means these two x's need to be replaced with 8, and see what comes out, and that will be your answer for letter A. Letter B is very similar, except this time you're going to evaluate h of 12. All right, both of these x's are going to become 12. Just plug them into your calculator. Don't forget that v is given as 28. I'm going to have you skip part C, and then see if you can come up with the answer to part D. Part D says the center of the hoop is 10 feet above the floor and 15 feet in front of the foul line. So will the ball go through the hoop? Why or why not? Well, given what we were told earlier, just using this same function and evaluating h of 15, I want you to see what comes out, and that's going to be the height of the goal. And something interesting should happen. I hope if you know anything about basketball, you know that the hoop is always 10 feet high. So with h of 15, meaning that he's 15 feet in front of the hoop, and the max velocity is still, or the velocity is given as 28 feet per second. Will this ball go in, and why or why not? And then what you're going to find out is it's not. Okay, I'll just go ahead and set you up. It's not going to go in, and just be ready to tell me why. Well, it's all about the initial velocity. We can't change the fact that the goal is 10 feet high. You do stand 15 feet away. That's the rule. But the initial velocity given in the previous in the instructions, suppose a player shoots a ball with an initial velocity of 28 feet per second, that's going to be the issue. So we need to know what that initial velocity does need to be in order for this shot to go in. Alright, so I hope I've helped you there. See what you can do with that. And if you have questions, of course, you can email me or come and see me in academic support. But I think I've set you up pretty well, especially here. If you just assume 28 feet per second, those should not be any problem. Maybe here when you get to this part, and if you have questions, you're always welcome to see me. But this is the assignment. This is what we're going to work on. And again, you can omit part C for number 29. And I hope this helps. If you need me, just let me know.